So coming to Dockers, Docker technology and virtualization technology, they both do the virtualization, but in some different ways. So Docker has its own advantages, VM has its own advantages. So let's go on the board and discuss few things. So we discussed, we have a, oh come on, I think my son has got access to the marker. He ruined it. Okay. We had hardware, we had OS kernel, and then we had VMs. The VMs had virtual hardware.
Zishan bhai, what is the difference of VM and containers?
That's what I'm telling.
Okay.
And the app. Marker is ruined. Come on. Blue one is, I guess, better. So in case of a VM, this was our hardware, this was our OS kernel, and on top of that, we install a virtual machine that virtualizes hardware, like it takes storage from this machine or shared storage. It has its own kernel, and there is some app running on it. This is the concept of a virtual machine or virtualization. So if you have OS kernel, maybe Windows or Linux, it doesn't matter. You can have Windows server running on top of it, you have Linux or any other distribution. So what's Docker? You have hardware, you have OS kernel. Till here, both are the same.
The screen is not fully visible, just a little bit.
Okay, it's a bit.
The borders are missing.
There is the border, don't worry. I'm not writing outside the border. It's almost there. So in virtualization, you install a virtual machine by installing the operating system through some ISO or disk. So the size of VM is maybe, at least if it's a minimal install, even it is about 400 MB and goes up to GB. But what is containerization? Container works in layers, okay, in an isolated environment, just like a VM. But it uses, if this is a container, there is an app, and we all know that if we install Apache, we have some dependencies. If we install MySQL, MariaDB, we have some dependencies. So it has some libraries or dependencies, and they are packed together in a container. Container is what? Container, the word Docker, container, these are all shipping terms. So one container in a ship is packed with everything what someone has asked, and it uses the kernel of this host. It doesn't have its own kernel. So now you don't need to install the operating system. You just need to pack the application and the libraries or dependencies related to that app, and it will use the operating system kernel. The advantage is application size may be 40 MB because you don't have operating system and kernel installed. So it is very easy to move the container, to copy the container, to download or upload the container. But there is a limitation. If you have built your app in Linux and you are running Dockers on Windows, so Windows has different kernel, and Linux behavior or Linux app is optimized for Linux kernel. And if the application is made in for Linux, it will not run on Windows kernel. If you have application that supports Windows, it will not run in Linux kernel. Okay, why? The very important question here is, if we had VM available, why we are switching to containers or container? Why we are doing the containerization if virtualization platform is so stable? There is one problem with virtualization solution. Maybe we have a developer. Habib is a developer. Habib has some tools installed in his laptop, and he developed a code. Okay, there are some quality assurance or testing guys available in the company. So Habib gives them the code, and he gives them the complete instructions how to prepare your machine and how to run that code. Maybe Habib is sitting on Mac. Harshada, who is a quality assurance person or resource, she might be sitting on Windows, and Mohsin
I'm on
might be
Ubuntu.
sitting. You
Ubuntu.
will be on Ubuntu. So everybody has different environment.
Mm.
And because Mohsin is developers, he's so expert that he gives you the instructions in a manual or some text, some notepad that just enable these things. And maybe either he forgets something because he thought it is understood, or maybe this instruction is not clear, or maybe you have understood it wrong. And the third problem is the environment is different. So you don't know how the application will behave. And there is always chance of human error in deploying or following that guide. So containerization is like you pack this container, you push it to some repository, the testing guy will download it, and this container packs everything, and it doesn't care what steps are involved to sorry what steps are involved to install this or run this application. The container is packed with everything, every same version, all the libraries, dependencies, and everything is packed in that container. So you just have to download it. Okay, no matter if you are on Linux, CentOS, RHEL, Ubuntu, the Docker commands will be the same. So it gives everybody the same environment, same commands, and same behavior. Plus, you can clone it faster. Any confusion till here?
No.
So the difference of a container between VMs, I think it's clear, Harshda?
Yeah, Jishan, I mean,
Good.
yes,
And
so
till
far so good.
Lakshmi, so far so good. So there is a difference
Yes,
between
good.
container and VM, and there are advantages and disadvantages of both. So Okay. Another advantage is you have to clone a window. I mean, the size is very big. As I told you, it's 1 GB, and if you want to make 100 clones, so it will be a very lengthy process. And it will copy the hardware configuration, the OS configuration, I mean, the kernel and the app. The container works in layers. So it works in layers. Every container is built on some layers. Like you have Java application layer, you might have OS like mostly Alpine OS is used, a very small OS footprint. You can have your custom OS or you can have Alpine. Alpine is has a very small 20-30 MB footprint. And so on. You may have, let's say, Nginx or MariaDB. So you have layers. So this layer, this layer, this layer, this layer, this layer, everything is stacked on another thing. So if you have downloaded a container which is, let's say, Nginx latest, in YAML, we write the tag as latest, and you have Nginx 1.12. When you will download these two containers, when we will practically see it. So when you don't download the first container, it will download this layer, this layer, this layer, this layer, this layer, this layer. And your container images downloaded and you can run it. Let's say we need to install Nginx 1.2. So basically, Nginx 1.2 has this, and this layer all the same. So it will not download it again, and it will only download this part. And the beauty is, as this part is already here, so these are probably some libraries and dependencies. So it will use these files. So now both the containers will be using these files, and the new container will have only these two layers downloaded. So it means if the container type is same or you have different versions of the app, you are again further limiting the download size. Any confusion till here? I mean the layers concept.
Yeah, good.
Good. So
Yeah.
the other advantage of containerization is I have an Nginx version latest 1.12, 1.02. In a single VM, we can either have Nginx running, we can either have Apache running on port 80 by default. If we want to run both of them, we have to change the ports. But in Docker, you can deploy any number of Nginx servers without changing any configuration. You can run 100 Nginx servers. All the contain in this container, every container will be listening on port 80. And there will be no conflict because this is a private space and it has no connectivity whatsoever with the main operating system, this OS. So it has no binding or connectivity. So every container is running on a isolated space. What's the advantage of this? And what's the disadvantages of this? Let's assume we have engine X, we have this engine X, and we have this Apache. Inside the container, Apache is running on port 80, engine X also running on port 80, and let's say engine X so let's say we have 3 containers running. They are running in an isolated space. This is virtually isolated, so the host doesn't know if what port they are listening on. So what we do is, this is our OS. So what we want to do is, we want to do the bindings that on this host IP, which is 192.168, let's say my IP is 255 dot, let's say 133. So port 80 will be bound to this container. When we make this binding, then the hosts can communicate with this Apache server. Now, what about this? We will say port 81 is bound to this container, and port 80 is bound to this container. What we cannot do is, we cannot bind 2 times port 80 with 2 containers, because when we will try to bind it, it will give you the error that the port is already utilized. So that's how we create the bindings. Okay, I think I think the grounds are prepared. So everybody would, I will recommend is everybody can use their old Linux machine, or they can do a separate Linux machine and practice what I am doing or I'm going to do now. Okay, fine, good. So I will share the installation documents with you guys later, because I have already installed the Docker package so that I can save some time. But let me tell you, cd etc yam.repos d. I have few repositories, like I have added Kubernetes repo and I have added Docker CE repo. I will give you these 2 repositories, and then what you will do is, we will install container, Docker CE, Docker CE CLI. These are few packages which will, okay, no, few packages are missing. Or maybe it's just updating the database. So we will install these packages. So every command in Docker starts from word Docker. So Docker push, Docker pull, Docker images, Docker run some image, Docker pull some image, Docker processes. So everything starts with the word Docker. Till it is updating the libraries, if you can ask something or you want to ask something.
What is Docker daemon?
Sorry?
Docker daemon. Daemon.
Docker daemon? What's a Docker daemon?
I mean Docker engine.
So I have installed the Docker engine, right?
Yeah.
So it's a Docker is a, I mean, it's an engine developed by Google. So I have installed it, and that's what I'm telling you, that I have Docker installed. And what you will do is start service Docker status. It is already running because I have started it on the boot time. But how we do it? Chk config chk. The screen size is okay for you guys,
Yeah,
or
yeah.
should I chk config docker docker on? Okay, so it is enabled on boot time. So let's see
Images.
if I have any processes or Docker is running now. I have any images, any Dockers I have ran before? No. If we have Docker images present, yes, I have few of them, and I can remove them by Docker RMI, the image ID or the image name. You'll see it has deleted couple of layers. So every app has some layers. We have PHPMyAdmin, so I can remove by image ID or by image name. So this also has many layers. So now I have clean system and nothing installed. Let's go to the public repository Docker Hub. Just give me a minute. So this is Docker Hub. Okay, Docker Hub, I have some, actually let me sign out because I have account, so it has already logged me in. Okay, Docker Hub is the official Docker's images repository. You can search MariaDB. So this is Docker official image for MariaDB. This is Docker official image for PHPMyAdmin. And you can have many MariaDB images available by many companies. Even IBM has. I don't know if it's IBM official or not, but anyone can push the image to the public repository, and you can see the number of pages for MariaDB. But I prefer is I always go for the official image. So these are the version tags. 10.11.2, it's the version, the MariaDB version. This is 10.7.8, it's the MariaDB version. 10.3 is the MariaDB version. So there is a concept of tags. Either we go with the latest, this is the latest, or we can go with the older releases if our app needs an older version of that application. We can find Apache here. We can find Nginx here. Let's say this is Docker Nginx image. And let's see, yeah, this is the latest image. And this is 1.2, 1.21, 1.22, whatever our developer wants, whatever our developer thinks that if his application will run in this Nginx version, so it will pack his application inside this Nginx, and everybody will be downloading that container in which this specific version is running, and the application will run smoothly. So the QA guys will be happy, the developer is happy, because the environment inside that container is the same. Because if you are using, let's say, 1.22, just open it. So this 1.22, I mean, you don't need to know everything. What I want to tell you is this is made from Debian. This image is based on Debian, so it doesn't matter if you are running a Ubuntu, if you are running Linux, the environment inside the container will be Debian, and our developer is tested it on a Debian and builds it on Debian, so everybody will have no problem. And the other thing is every container is made from some other containers, some other small containers. So this is one layer. So on top of it, he is doing some installations and running some commands. So that's how the container is built. And how we download that container, we just, let's say I want to download the latest Docker pull nginx. It is written on top here. So Docker pull nginx or latest or, sorry, I think, sorry, Docker pull nginx or nginx latest. Can you see the terminal?
Yeah,
Yes, yes. Yeah.
You can do the Docker nginx latest, or you can do 1.22. Let's pull this image. So, it is downloading the layers. And the size is what? 31 MB and 25 MB. This layer is 25 MB. This is 31 MB. This is maybe the OS layer, the Debian layer. So I have Nginx 1.22. I'm downloading it. And then I will install the Nginx latest version. So observe the time it is taking to download these two layers. And why we need to learn Docker? At least we should know how to run a container, destroy a container, pull a container. I I mean, you don't need to push a container, because at some point, let's say you get a job in a quality assurance team, and all the applications they are building are in Dockers. So at least we should know what Docker is, how we will pull Docker, and how we will test it. Otherwise, everything is packed inside a container. But we need to know how to pull and run that. Okay, so I have the Docker images. I have one Nginx image available with the tag 1.22, the version, the image ID, okay, created 11 days ago. This image was created 11 days ago, and the size is 42 MB. So now go with the Nginx latest version. Okay, when I will press enter, please observe that the download time will be reduced, and the few layers may not be downloaded again if both Nginx latest and the older release were from the same base OS. So I'm going to download latest here. And this already exists. So it has not downloaded this layer. Maybe this is the OS layer, which was 45 MB. And it is downloading only one layer, because I have selected a bit older version 1.22. So now I am downloading just this layer, this one, and the time is reduced. Now if I see Docker images, okay, DOC, Docker images, I have two Nginx images available. Now what I want to do is I want to run this image. So I will, come on, Docker run, and either the image ID. Okay, let's focus for image ID. So I am running this, and you can see Nginx 1.22 is running, built by this OS Linux, and start worker process, and Nginx is already started, and it can, process your requests on port 80. Now I am pressing Control C here. If I have pressed Control C, the container has stopped, and we can see Docker PS. I am writing DC. Docker PS, no process is running. And if I say, I think I should do is, give me a minute. I'm going to open actually two terminals. Okay. The class is complete. I was just checking it. So login as root, password is root123. And okay. So I can run the ID again, and I have opened another terminal, docker ps minus. So our Docker container is running. The container ID is this, the image ID is this, created 15 seconds ago, status is up. It is listening on port, but this port is isolated. It is a port inside the container. And when we will not name the container, the Docker automatically names your container. So if I press Control C, your container is gone. So if you do Docker PS, there is no container running, but if you do Docker PS minus A, you can see this one container image was built and this container image was built, but now they are in stop state. Am I going too fast, or you guys are good with it?
So now you're stopping it, you said?
No, I am saying these are the containers which I stopped.
Okay.
If you do Docker PS, it tells you the running container.
Yeah.
And minus A tells you
List of all.
the status is exited.
Mhm.
So whenever we run a command, a new container is created.
Okay.
And if you want to run the old container, so you can do is docker start with the
Container name.
container ID.
Okay.
We will discuss the names later. So we can start the container, the previous container again, and if we do docker ps,
Stop. Okay.
so it's the same container which is
5 seconds.
started. It is up. Okay.
Yeah.
Now, as you can see, whenever what we did was we pull the container, we run the container. If we do run MariaDB, what it will do is it will first search MariaDB locally if that container is already available, so that it can check which layers to be downloaded. So if we do the run command, it will execute actually two commands, docker pull and then docker run at the same time.
So before that, they show you if it's available in your
It is
machine or
checking
not.
locally. It is checking locally that if the MariaDB is already available in my machine. If not, then it will go on internet and search
Right
for
after that.
MariaDB.
Okay.
So I was telling you either we can pull and run a container, and if we do the run command, it will search that this container is not present. So it will then first it will pull and then it will run.
Mm-hmm.
Let it download, and so I have downloaded and ran another container. So let's see another terminal, docker ps. I think it's not clear. I think I should do is just take it here and like this. Maybe that's better. Docker ps. I guess this is better.
Mm-hmm.
So we are still waiting because the second container is not up. MariaDB is a big OS, I guess. It's pulling 87 MB, but it is better than a virtual machine, which can take at least up to 400 MB minimum. And if you do the text, it is for if you do the text and minimal install. If you use the graphical user interface, it will go like 1 GB and plus. So in that case, Docker image is very small and to
Lightweight.
run lightweight, and you don't need to run the okay. So so all the things you need to set, the root password and everything else. So I was saying, if we do nginx and nginx is running, but when I press the Control C button, nginx is gone. I think I don't know what this docker stop. Okay. So nginx is closed. So for that, we run nginx in detached mode. But before that, let's say if nginx is working or not. What we will do is docker run -p, let's say port 6000 and :80, and the container name is nginx. What I am doing is I am running nginx container on my host port 6000, which is mapped to a port 80 inside the docker container. Okay. So if I do this, docker ps, my container id, image id, port 6000 is mapped to my container on port 80. So what I want to do is, let's go on my browser 192.168.255.133:686,000. Why it is restricted? Okay, it's Firefox. Firefox is saying that due to security reasons, I'm not allowing you this port. So let's see if, let's change the port. We can do it 3000. Let's see if our browser have problem with port 3000. Yes,
Mm.
3000 is fine. I mean, I assume what port 6000 does is, if all the browsers are so curious about this port that this is used for some other thing. Anyways, and you can see if I refresh the button, I have request coming into my Linux container, and this is my Nginx. And when I will press the Control C button, and if I go to the browser, it will not work. So now we know that this Nginx page was coming from inside the my Docker container. And I can say that run in detached mode or daemon mode so that you can do some other work. And this is now, I mean, always running till your system restarts. So now Docker ps, I mean, let's clear the screen. Docker ps. So now we have this container running on port 3000. What I can do is I want to show you that I can run another container on 301, another container on, you know, when we were cloning Windows, you first have to clone it and then you have to run it. But you see, that's how a container is spent. It's so simple. And if I want to do it on 304, okay, let's say 80. And if I want to do 80 again with Nginx colon 1.12, it will give you error. Okay, it is saying first I have to download it. Okay, I think I have removed this version, so it's downloading. Oh no, I have actually downloaded 1.22 and I said download 1.12. Let's go to the other tab till it is downloading. So now Docker ps. So you can see inside all containers are listening on port 80 and outside 301 to 304. And this is how speedy you can spin a container. Way faster than the virtual machine because the OS is not booting, the kernel is not booting, just the application is powering off. So
Okay.
3001, it is
Not
Nginx.
in.
3002 is Nginx. Sorry, Musin, what were you saying?
No. My mic is on.
Okay, 303, 304. So we have multiple Nginx running inside our host, and we did it just like that. And if I want to stop it, then I will do docker stop and the container ID or multiple container IDs. I'm in 46. So now docker ps. We have no container, but docker ps minus a. We have created all these containers and they are all exited. There are many more commands and concepts, but I think I should hold here today. You can do docker pull, you can do docker run, you can do docker ps, you can do ps minus a. You
Start stop.
have start stop. You can do is uh, you can see your images. You can RMI means remove images. You can remove. Okay, actually it is using. I have created, I guess, some. I have used this image. Yes, with this container is using this image. So first we have to delete the container and docker ps minus a rep. So this is the container which is made from that. So first we remove docker rm this, and now I can do No, all the images are from this container. So I can do is RMI Docker images. I can delete this one because I have not used it. Docker and Docker RMI nginx colon 1.12. Okay, still some container is okay. First, we have to remove all the containers, and then you can Docker ps -a. So we have to remove all these containers before deleting the image because these containers are using the image.